All right. We learned how to do. Okay, Ashley's running back and now going off. Okay, very good. Enjoy. We learned how, well, I taught you how to do some naming of ionic compounds with polyatomic ions. I'd like to go through at least some of these to make sure that we're getting them. Now, you need to be able to go from the name to a formula and the formula to a name. That's important. And you also, and this is going to be extremely important as we move forward, you have to be able to recognize that for ionic compounds, they always start with a metal. They always start with a metal with some sort of a charge on it. The only ionic compound that does not start with a metal is something that starts with NH4, ammonium. So that's on your chart. The reason I'm talking about this starting with a metal is because when we talk about covalent compounds, they are made up of non-metals, and we have to look at them a little differently. So I'm just going to go through and write the formulas for some of these. So hopefully you got them too. Let's take a look. They say number one is lithium acetate. The symbol for lithium is Li. It gets a +1 charge. Acetate has a -1 charge. So there's your formula for lithium acetate. You could also write it this way. Okay, either way is perfectly acceptable. I like to write it this way because it reminds me that this is coming from what we're going to learn to be a carboxylic acid. This comes from acetic acid. Don't worry about that now. Either way is fine. Okay, iron 2 phosphate. Well, that 2 in the parentheses means iron has a +2 charge. Phosphate has a -3 charge. Okay, so we have to do that old, put the 2 down there and the 3 down there. So Fe3 parentheses PO4 2. You have to have that parentheses because everything in that parentheses there's 2 of them. I'll write up here because I think my computer's blocking it. So Fe3 parentheses PO4 2. Okay. Now keep going here. I'll erase these. I might as well just chug through most all of these. Titanium 2 selenide. Now, selenide, some people were having some trouble with that yesterday in third period. If you look at oxygen on the periodic table, oxide gets a -2, sulfide gets a -2. So what do you think selenide's going to get? -2. They're all in the same column. They're all in the same family there. So titanium is a +2. It tells us right in the old parentheses there. So just be TISE. TISE. One little, well, I don't want to confuse you. I'll talk about that when we go to covalent compounds. Calcium bromide, that's just CaBr2. Remember, all of the ides, if it's bromide, sulfide, iodide, they all come from just the elements. The only ide that is a polyatomic is cyanide. That's the only one with an "ide" ending. All the rest, well, you just have that sheet. You just look at the names. Let's gallium chloride. Let's skip that. Sodium hydride. That's an interesting one because hydrogen can either get a +1 charge or a -1 charge. It's a very interesting element. So sodium hydride is just NaH. I tend not to ask about hydrides in this class because you don't see them too often. 99% of the time for us, hydrogen is going to have a +1 charge. Okay, now we're finally starting to get to some polyatomic ions here. So beryllium hydroxide. Beryllium is a +2. It's in the second column there, the alkaline earth metals. So that's a +2. Hydroxide is a -1. Just look at your chart. No, not brain science here. So you put a 2 there. Zinc carbonate. Zinc always gets a +2. That's why there's no Roman numeral there. And carbonate is CO3. That has a -2 charge, that has a +2 charge. So there's your formula for zinc carbonate. Now, here we go. This one's a little strange. Manganese is very interesting. It can get really a big charge on it. And this is manganese with a +7. Right? And they say arsenide. Now let's take a look. Nitride gets a -3, phosphide gets a -3, arsenic, when it becomes arsenide, would have a -3 charge. So AS -3. So we make the formula. Let's put the 7 down there and the 3 down there. And we have that crazy looking compound. We don't see too many compounds where we have such a high charge on a cation. Okay. Let's see here. Well, let's look at copper 2 chlorate. Copper's +2, chlorate's -1, ClO3. So I need 2 of those. Cobalt 3 chromate. I gotta double check. I don't look at chromate too often. Oh, it says -2 charge, right? So this is CO with a +3 charge, CrO4 chromate with a -2 charge. So bring the 3 down there and the 2 down there. CO2 parentheses CrO4 3. Okay. Ammonium oxide. Well, ammonium's from your chart. NH4 with a positive charge, and oxide gets a -2. So I'm going to need 2 of these guys. Oh, that's it. We're done. Potassium hydroxide. K +1, hydroxide -1, KOH. Lead 4 sulfate. So lead has a 4 +4 charge, or +4, and sulfate has a -2 charge. So we have to have 2 of these because I want to get a -4. I mean, remember I said you could bring the numbers like that? But if there are 2 numbers that are, if one is divisible by the other, if I wrote this, PB2SO4 4, well, that's not correct because we could reduce those numbers. So this trick only works if you have to find a least common multiple. In this case, we just have PbSO4 2. Okay, silver cyanide. Ag always gets a +1, always. Cyanide is a -1, so there's our chemical formula. Vanadium 5 nitride. Here's one where we could do that trick. Vanadium is a +5, and nitride is a -3. So we can do that little thing there because we have to find the least common multiple. So V3N5. That would be our chemical compound. Strontium acetate. Strontium gets a +2 charge. It's an alkaline earth metal cation. Sr, and then acetate is -1. So I need 2 of them. Let me think what else we've got here. Molybdenum sulfate. I can't even say the word. Molybdenum sulfate. Where is molybdenum? That's one I barely ever think about. Oh, chromium molybdenum. I can't even say that one. Skip that one because they don't tell you the charge on it. I guess we can assume it's just going to be MOS for that one. Platinum 2 sulfide, PTS, and then ammonium sulfate, that's NH4. I need two of them because sulfate has a minus 2 charge on it. That's it. Molybdenum, there it is. All right, new topic, and then I'm going to let you work just for the rest of the period. I want to talk about covalent molecules. Molecules and ionic compounds are different in that ionic compounds are held together by charges, by the attraction of opposite charges, whereas covalent, they share electrons to get their shells filled, the so-called shells filled. And when we study the bonding, we'll get more into that. But right now, just understand that they are two or more non-metals bonded together. And consequently, since they're sharing electrons, we can get all sorts of ratios that are formed. Everyone knows what this is, CO2. They talk about it all the time. People get all freaked out about it because, so-called climate science. It's carbon dioxide. It's also the fizzy stuff in my Dr. Pepper. CO is carbon monoxide. You breathe that in, you die, if you breathe in enough of it. Now, how do we go and name these things? This is the easiest thing ever. You need to write something down in your notes, though. Numeric prefixes. Numeric prefixes. All right. Mono, 1. Di, 2. Tri, 3. Tetra, 4. Penta, 5. Hexa, 6. Hepta, 7. Octa, 8. Nona, 9. It's a weird looking 9. It's also, if anyone's Italian, if you have a grandmother, you call her Nona. And Deca, 10. So we are going to use these when we go ahead and start naming our compounds. So we'll take a look at a few of these. I'll leave these up here. Try to move the camera a little bit. And I'm going to show you through examples the rules for naming these compounds. We just saw two chemical compounds, CO2 and CO. If the first nonmetal element in the compound is just one of them, we don't give it a prefix. We just say carbon. But I have 2 oxygens, so I have to say carbon dioxide. I only have 1 oxygen here. Remember, I have 1 carbon, so I don't have to give that a prefix. This is carbon monoxide. Okay? And notice, carbon monoxide, and I said the prefix is mono. Well, this is a kind of a goofy thing in the rule. If your element begins with a vowel, you drop the vowel on the end of these. You don't say monoxide, monoxide. So I'm going to keep going with some examples. Let's say I look at a series of nitrogen compounds. These are all chemical compounds made up of nitrogen and oxygen. Some of these gases are very toxic, very poisonous. This one, back in the day, they used to give it to you at the dentist office when you're getting your teeth drilled. It's called laughing gas. Just put the old mask on and you didn't care what they did to your teeth. So, if the first element is only one, you don't say mononitrogen. You say nitrogen monoxide. What do you think this one's going to be? Yeah, there's nothing to this. It's good. Good job, Noah. Nitrogen dioxide. Now, we have a chemical compound with a 2 here. So we have to call that dinitrogen monoxide. Dinitrogen monoxide. This has a common name. It's called nitrous oxide. And that's what they used to give you at the dentist. They still use it in whipped cream containers. And so you can propel out the cream. All right, using our things here. I got N2O4. Any guesses on what we're going to call that? What do you think, Sam? How can we name N2O4? Look at our...
dinitrogen tetroxide.
Good. Drop the A. Dinitrogen tetroxide. You're golden. That's it. Notice 2 nonmetals. This is a real chemical compound. Connor, what do you think we call this one? We got 4 phosphoruses.
Tetraphosphorus decoxide.
Decoxide. Yeah, drop that vowel. Nothing to it. So pull out your sheets, and there are a bunch of them on here somewhere that are covalent compounds. Oh, before I go on, there are several covalent compounds with common names. All right, common names. We don't call this dihydrogen monoxide. What do we call it? H2O. Water. Yeah. You could call it dinitrogen monoxide. That's a dihydrogen monoxide. That's not wrong, but it would look a little cumbersome on the label of Deer Park. The next one is NH3. That's ammonia. Not ammonium, it's ammonia. And finally, CH4. That's one that's pretty popular around here. It's called methane. Methane. So these 3 have common names. There are a couple others, but I'm not gonna worry about those right now. So okay, I hope this will help if you get stuck. And looking at the worksheet, start identifying the ones that are non-metal to non-metal bonding. And if you have to use your periodic table, then by all means, please do so. And that's about it.